All right, Workplace 30. Here we're talking about Chapter 5 here today. You have your test tomorrow. So Workplace and Apprenticeship 30. Oh, there we go. That screen is unfrozen now. Thank you. So we're talking about Chapter 5, and I'm going to go over the highlights. I'm going to do a couple practice questions with you. Probably get you guys to do some questions as well in review, just from the review here, just to make sure that you can actually do what you need to do for the test tomorrow. So in Chapter 5, we're talking about properties of geometric figures. Whoa. I guess. All right, so properties of geometric figures. So in 5.1, we're talking about triangles, and you guys should be well aware of what a triangle is. A three-sided figure, okay? Some special triangles, one of the special triangles is a right triangle, a triangle that has one 90-degree angle in it, right? That's right. And so in a right triangle, we have some very special relationships that we need to be able to use in order to solve for missing parts of triangles. The first one that you've been working with is the Pythagorean theorem. So the Pythagorean theorem states that for a right triangle, that is a triangle that has a 90 degree, that a squared, so the square of a plus the square of b equals the square of c. A squared plus b squared equals c squared. And of course, if you're given any two sides of a right triangle, you can always solve for the third one. Just plug in the appropriate numbers here in this equation and then solve for the missing value, okay? So Pythagorean theorem is something you've worked with for a very long time, and just to give you an example here, let's say this would be 3 and this is 4, and I don't know what the c is. So what you would do is you would understand that the 3 and the 4 are the legs of the right angle, or the legs of the right triangle, and so they're A and B. C is the hypotenuse, or the largest side always. So you would say 3 squared plus 4 squared equals c squared. You see, I'm just plugging that into the equation. These numbers go on the left side there. So if I evaluate that, that's 9 plus 16 equals c squared, or 25 equals c squared. Now, how do I get c all by itself here? What do I have to do to both sides? Take the square root. Very good. So if you take the square root of both sides, you end up with c equaling 5, right on. And my program just completely crashes. So c does equal 5, whether this computer wants to admit it or not, but c equals 5, okay? So that's Pythagorean theorem. Any questions about the Pythagorean theorem, also called Pythagoras' theorem or whatever? You guys good with that? Everyone understand? Be able to work with that? Okay. So another thing that we need to know about triangles, I'll just zoom in here and make that a little bit bigger. In a right triangle as well, the other thing we need to know is SOHCAHTOA, okay? Very important. Pythagorean theorem and the trigonometric relationships, or the trigonometric ratios, trigonometric functions, whatever you want to call them. Sine, cosine, and tangent. Now, this has to do with an angle now. So now we have to introduce an angle. It's not just the sides. It is in reference to an angle, okay? And remember the SOHCAHTOA that I just mentioned. So is SOH. What does that mean? Sine equals opposite divided by hypotenuse. That's the SO. Sine equals opposite divided by hypotenuse. The CA, so CA is CAH. And of course that is cosine of an angle equals its adjacent side divided by hypotenuse. I'll talk about adjacent side in a minute, but TOA is the TOA, and that is tangent of an angle equals the opposite side divided by the adjacent side. So let's say we're talking about, in this example, let's just use this example, and let's say I'm talking about example or angle B here. So this is angle B in our example. Okay. Now this has nothing to do with this actual question. I'm just using this triangle. And as a matter of fact, maybe what I'll do is I'll just take a photo of this triangle with angle B, and I will maybe do something with it down here. Okay. So it's not this exact question, but let's say for angle B, I want to know what is the tangent of angle B. Tangent. Well, the tangent, remember, it's TOA. So tangent equals opposite side divided by adjacent. So let's figure out what side is what. for angle B, the opposite side, if you start with the very vertex here of B and you draw a line through the middle of the angle, the side that it touches on the other side, that's the opposite side, okay? It's the exact opposite of the angle, right? Now this one, the largest angle and the one that's opposite of the 90 degree is always the hypotenuse, always. So that leaves this one as the adjacent side. And so it's right next to the angle, but it's not the hypotenuse. So that's the adjacent. And sometimes that's the toughest one to identify. Okay? So tangent is opposite side, which is in this case 7.6 centimeters, divided by the adjacent side, TOA, divided by 9.4. So what that says to me is that the tangent ratio for angle B, I don't even know what angle B is yet, but the tangent ratio is this 7.6 divided by 9.4. So let's just do that on our calculators. 7.6 divided by 9.4. Okay, 0.8085. Okay, 8085. Now that is the tangent ratio for this unknown angle B. And what we can do is we can solve for the unknown angle now. Because I know its ratio, I can figure out its angle. That's the beauty of these trig ratios. So how do I find angle B? Who remembers how to do that? Can shout it out. Inverse, right. So on your calculator, you should have a tan to the -1 button. And if we do that to both sides, you see what we get. We get tan to the -1 of this ratio. That and that, the tan to the -1 and the tan are kind of like they cancel each other out. So we have angle B equals, and yes, you're absolutely right, I'm going to take the second function tan, okay, and I'm going to write this 8085 or 0.8085, and I'm going to use the entire answer, all of the decimals to get the most accurate number. Oh boy, I got to check my mode here. This silly calculator, okay, this is in radians. We want this in degrees for simple trig ratios. Sorry, that was the default here. So let's try that again. Let's do that entry again. And tan of, okay, I feel like I got to do this all over again. So tan, second function tan of, what's this ratio? 7.4, and you can go right from the numbers there, divided by 7.6 divided by 9.4, and that's going to be 38.9. Okay, did you guys get that? Now that I've messed around with these, make sure it's on degrees. Make sure your calculator's on degrees so you don't mess up there like I did. So 38.9, or that would be 40 degrees. 40 degrees. You can round that to the nearest tenth of a decimal place there. Okay, 38.95 would be 40. 39. Okay, any questions about that? 39 degrees. So that's also important, using those trig functions, right? The other thing we can do here, and I'm just going to double check my next page so I don't get ahead of myself. Okay, so that's Pythagorean theorem questions, which we don't probably need to do right now. So, yeah, okay. So here is a question, and I'm going to probably do one with you and maybe get you to do one too. So the trig ratios are really important because we can solve for missing sides, even though we don't have two of the sides of a right triangle. So if we can't use Pythagoras, but we have an angle measure, we can use the trig functions. So in this case, I would use one of sine or cosine or tangent to solve for x. So how do we do that? This is how you do that. You would write an equation involving the angle, the given side, and the unknown side. And there is one of these trig functions that I can use to write an equation where there's one unknown value. So this right here is the angle 27. I am given 2.8 is the hypotenuse because it's opposite of the 90. Perfect. So hypotenuse. So I'm going to use either sine or cosine looks like because I want the opposite side. Which one am I going to use? O and H I'm going to use? Sine. Very, very good. So what does that look like? Well, sine of the angle, make sure you put the angle in there. Sine of 27 has to equal the opposite side, which is unknown value x, divided by hypotenuse, or 2.8. Okay? So always start off with the equation. Write out the equation just like that. Don't skip any steps, okay? Write out the equation. Now you're going to want to multiply both sides by 2.8. Okay, and this is very good to show me that you know exactly what you're doing and how you're getting your answer. Don't just show me an answer without showing any work, right? Communicate, okay? So I can give you full marks and full credit that you know exactly what you're doing. And then you're just going to do that on your calculator now. Calculator. Your calculator. Does it sound like calculator to you? It sounded like calculator to me. All right, so 2.8 times sine of 27. Now remember, sine of 27 is just a ratio. It's just a number. It's going to be like a decimal, right? That's all it is. So let's see what that tells us. 1.27. Okay? Looks like 1.27. And of course, we're going to use our units there. Centimeters are given in the question. Now, tell me you guys got that as well. Did anybody else do that on your calculator? Okay, you better double check my work here because I've only got this fancy virtual calculator, not a real one.
No, we wouldn't round it, right? 'Cause it's only one.
Well, you could round it. That's a good question. You could write this as 1.3. Yes, you could totally do that. Why? Because the question just has one decimal place there. So yeah, you could totally round your answer. If you're unsure, I usually say go 2 decimal places. You know, the more the merrier. If you're unsure. Did you get the same answer? Awesome. Okay. All right. So I want you guys to do letter C here. So take a moment, and I'm going to get you to copy this down. You can draw the diagram, or you can just show your work. I'll leave this up on the screen for a minute. I want you to do it, and then I will show you my answer in a minute. Okay? So go ahead and do letter C right there.
Oh yeah, Mr. Maxwell, could you?
All right, so here's the answer to letter C. Now, 62 is the angle. X is the hypotenuse. It's always opposite the 90. The adjacent is 3.3. And this is why I ask you to always start with your trig equation, just so that you make sure you get the numbers in the right spots, okay? So cos, you're going to use cosine because it's A and H, right? Ka, so ka, toa. Cos of 62 equals adjacent 3.3 divided by hypotenuse, which is the x. So if you multiply both sides by x, the x goes up to this side. If you divide then by cos of 62, the cos of 62 then goes down here. And so they can switch. Across the equal sign, those values can always switch. Okay? Across the equal sign, those values can switch. So we have x equals 3.3 divided by cos of 62, and you should get 7.0 to the nearest tenth there, centimeters. So again, on your test for full marks, show this equation, show the manipulation of this equation, show your answer, make sure you have the right units, and make sure you circle your answer, okay? And try and make things as clean and clear and thorough as you can. Any questions about that?
No.
Okay.
Figured it out.
Awesome. Okay. All right. So let's see. Moving on. What else do I have here as far as review goes? All right. Let's talk about this. This is a big part of this section as well. I think we might be in 5.2 by now. I'm not sure. Is this 5.2? Anyways, triangles classified by angle measure. Okay. So this is really important. If you have a triangle where all 3 angles are less than 90, that is an acute triangle. It's a cute little triangle. Aw, those angles are little, and aren't they so cute? Oh, that's so cute. It's a cute angle. I like to just pinch the cheeks. It's so cute. So that's how I remember. All these little tiny angles, like little tiny kids. Oh, it's a cute. Okay? So if I see you writing your test and you're like, I'll know what you're doing, okay? It's not, you won't be crazy, all right? Now, a right triangle, of course, a right triangle has that 90 degree in it, right? And so if you look at this, a triangle could have an angle greater than 90 degrees, or it could have an angle that is 90 degrees. You cannot have 2 angles that are 90 degrees. And you cannot have 2 angles that are greater than 90. And why is that? Well, if we had 2 angles that were 90, the triangle might look something like this. And that's not much of a triangle, is it? No. Because these lines are parallel and they will never meet. So we have to have a closed figure. You can have one obtuse angle, but you can't have a second obtuse angle because, again, those sides will never meet. So you can have one right triangle, one right angle or one obtuse angle, but you can never have more than one. A right triangle has a 90 degree, and obtuse angle has one angle that's larger than 90. And it has to be also less than 180 as well, because if you had a 180 degree angle, then look at the third side here. So if this is 180, the third side is going to be right along this line, and that's not much of a triangle. That's still just a straight line. Okay, so yeah, and if it's greater than 180, let's say this was the angle, like 230 or something, well then how are you going to make a straight line that goes from here over to here, that goes around here? You can't have a straight line. It has to be curved. The only straight line you could have is from here to here, right? And then this angle 230 would not be in the triangle. So you can have something called an obtuse triangle as well, with one angle between 90 and 180. Okay? So that's how you classify triangles by their angle measures. Any questions there? All right. Okay, how do we classify triangles by their side length? Well, here's this little chart on page 180 of your workbook. And the first type of triangle, if all the sides are equal, doesn't matter what the length is, if they're all the same, that is an equilateral. Now, if we take this word apart, you see sort of equal in there, right? The first part is equal. Lateral would be like the sides. Side, lateral, the sides. So they're equal sides. Think of it that way. Really, really easy. Equilateral. Three sides are the same. If we have two sides that are same, this word has always just been amazing to me. I love this word for some reason. It's such an off-the-wall kind of word. Like, it's just so strange. And I don't know how to help you to remember this word isosceles with this triangle other than just memorizing it. Isosceles. I don't really know. Isosceles. Isosceles, and then he ran away. I'm not sure. I'm not sure who Celes is or why he ran away from you. I saw Celes, yeah? Did you see Celes? Anyone? Yeah, I saw Celes. Do you get it? Do you get it? Yeah, I know, lame. Corny, lame math teacher joke. All right. So, I'm honest. Isosceles, two angles the same. Just two. And consequently, these angles here, two sides the same and two angles the same, those will also be identical, okay? And this will be symmetrical if you draw a line through here. That will be symmetrical, the same on both sides. And then this last one too, also another little bit of a funny word, scalene, okay? Scalene. All sides are different lengths. And notice that a right triangle, that is categorized by its angle, right, but it can also be a right scalene triangle because all of the sides can be different lengths. So you can have an obtuse scalene, you can have an acute scalene, or a right scalene. Scalene simply means that all of the side lengths are different. And again, scalene, I'm not sure. What do you think about that word? Scalene? A reptile, yes, like scales or something. Like you got scales. A fish is scaly, or scalene. Maybe you name your lizard that. I don't know. Meet my lizard, scalene. Or I got to get over that wall. How am I going to do it? I'm going to scalene the wall and jump over to the other side. I don't know. I'm not sure what that has to do with anything. Okay. As we move on, what type of triangle is this large one right here? This large ABC triangle? Shout it out. Isosceles. Very good. Why? Because this marking is the same as this marking, which means that those two sides are equal. So what can you say about angle C, everyone? Come on, help me out. 53. It's 53. Thank you. It's the same as this angle right there. That is the same as this one. Wonderful. All right. Who's going to ace this test? You guys. Awesome. Okay. Please remember, when you were back as a little bitty kid in elementary school, you learned the area of a triangle, and you need to have that memorized. You need to know that without the shadow of a doubt. The area of a triangle is 1/2 base times height. Or you can think of it this way, base times height divided by 2. Okay? You need to know that. So if we have this equilateral triangle right here and I want to know the area, well, area is 1/2 base times height. Or as you see over here, base times height divided by 2. That's exactly the same thing. The base, okay, the base would be right here, one of the sides. And the height would be the line that is perpendicular to that base. Now, we know what the base is, but we have a bit of a tough time knowing. We don't know what this is right now. It's not 30. Okay? So if I know what the base is, but I need to find this height, how do I go about doing that? Can anyone give me an idea for this question how I go about finding x, w, or wx there? Yeah.
You can divide base by 2 and then use Pythagoras theorem on half the triangle.
Okay, so I can divide the base by 2. Very good. That is totally true. And then you said I can use this triangle as a right triangle. Well, that's the worst line ever. Anyways, but yeah, you got it. You have a little right triangle there. So watch this. Let me just see if I can do this over here. So I'm going to have 15 squared right here plus h squared right here, okay, equals what? Or 30 squared, yeah. A squared plus b squared equals c squared. Or in this case, 15 squared plus h squared equals 30 squared. And so yes, you can go ahead and do something like this. So h squared, what's 30 squared? That's 900 minus 225. What's that? 675. H squared equals 675.
That's impressive.
What's the square root of 675? I'll let you guys help me out here now. Is 26, I believe is correct. Do y'all get 26?
Yeah.
Even or
Decimal, but
point
it
what?
comes up to
26
26.
point?
It's 25.59.
Oh, 25.59? Okay. Yeah, whatever. 25.59. Is that what you got to?
No, I got 25.98.
25.
Was I
So we got 25.98 maybe?
yeah.
I tell you what, let me just check. Okay.
I think that's a good idea.
Let's see if this calculator knows that one. Square root of 675. And the winner is 25.98. Okay. Which can be rounded to 26, which is where we were at the beginning. Awesome. Okay. And centimeters. Now, is that the end of the question? No. So when you're writing your test, please make sure that you don't stop halfway through a question. You always, when you think you're done or when you think you might be done, go back to the question and make sure you're done. So notice, and this is me, look at this. I circled 26. Well, we're not done, are we? That's just the first stage of that question. What is the area? So I look back here and I say, oh, right, area. I'm not done yet. So that's what you guys do. So if I'm going to use 26, or maybe I'm going to use this decimal, that would be even wiser. Now I'm going to go back to my area and I'm going to say 1/2 times the base is 30 times the height is, let's use this full decimal here, or something, 2 decimal places is good. The more decimals you use, the more accurate your answer is going to be, precise too, okay? So area equals, that's going to be 1/2 of 30 is 15 times 25.98, okay, 98 times 15, 389.7.
Yes, sir.
Okay, area is 389.7. And I'm done, right? Just like that? Am I missing anything? Would I get full marks on the test? Units, thank you very much. Area. So centimeters.
Squared.
Thank you. Centimeters squared. Very good. So look at that. That's a model question right there. Okay? Write out your formula. Figure out the pieces that you need. Plug values into the formula. Show your steps. Circle your final answer with proper units, 100%. Okay? All right? You guys can all do this. Very good, very good. Okay, moving on. So there's a long review. We're about 2/3 done here at least. Quadrilaterals, that was only 5.1. Whoops. Okay, 5.2 now. This one's shorter though. 5.2. Okay, so there's a couple of terms you need to remember for the test here. And one is a transversal. So a straight line that intersects 2 or more lines is called a transversal. So here in this picture right here, we've got line 1 and below it line 2. And the one single line that intersects both of those is called a transversal. So if if these two lines, line 1, line 2, are parallel, that is, they are equal distance apart and they never meet, okay, they're parallel, then we've got some special arrangements here. So 1 and 2, for example, would add up to 180. And let me just show you visually why that is. Because 1 and 2 add up to a straight line. See that? So these guys are called supplementary angles. Wow. All right, 2 and 3 are also supplementary. 7 and 8 are also supplementary. You getting this? 6 and 7 are supplementary, and so on. So anything that two angles that add up to a straight line or add up to 180 are called supplementary. Okay, what else do we need to know there? Okay, were there any other definitions regarding supplementary? Did you talk about complementary angles?
I was gonna say, are we having to name like exterior or interior?
Yeah, good question. Do you need to name these? I'm not sure if you need to name these. I'll go back to the workbook here and see if we can figure that out, but just give me a second. Okay, so the question was, do we need to know the names of the angles, like alternate interior angles or same side exterior or whatever? No, not really. That's not for this course. But what I will tell you, though, is that we've talked about a lot of supplementary angles, but if you notice, like, for example, 5 and 3, those are called alternate interior angles, and those would be what? Supplementary or something else?
There's something else.
There's something else, yes. What do they appear to be?
They're equal.
They are equal, yes. So when you're talking about parallel lines and transversals, all of the angles are either equal or supplementary. Notice this, 1 and 3. Okay, those are called opposite angles. Okay, two angles that share a vertex and made by two straight lines. Those are opposite angles. Opposite angles are always equal. Okay, so anywhere, this is equal to that. This one equal to this one. Opposite angles that are made from two straight lines. Okay, so I mean that kind of stuff you've probably learned in other math classes, but you don't have to know really much beyond that, okay? So this page here contains a build your skills question that I'd like to go over. And so just given this right here, it says in the following diagram, L1 is parallel to L2. Okay, good. These two lines are parallel. What are the measures of the indicated angles? Okay, so what kind of relationships can we draw here? Well, I know that 120 and the angle number 4 are what?
Supplementary.
Supplementary. So supplementary add up to 180, correct? So if we have 120, what do I have to add to 120 to get 180? Angle 4 is 60 degrees. Perfect. Very, very good. Now,
60 should be, or 4 should be equal to 3.
okay, and also, very good, 4 should be equal to 3 is correct. Those are called corresponding angles, and those should be equal. So, angle 3 is also 60. Very good. What about angle 2?
It should also be 120.
Angle 2,
Supplementary to 3.
very good. Angle 2 is 120 for two reasons, because 120 and 2 are corresponding angles and they are identical, but also 3 plus 2 should be supplementary. So 60 plus what? Well, 120. Okay? 110 and the angle 1, what relationship would they have, do you think?
They're the same.
Yeah, they're the same as well. Okay. So remember, when we're talking about parallel lines and transversals, the angles around that transversal, they're always supplementary or equal. When we have two different transversals, they may not be supplementary or equal. For example, 110 and 120. Those are angles associated with two different transversals, so the rules are off there. But if you just have one transversal, the pairs of angles are always either equal or supplementary. And that's a good thing to try and remember. Okay, good. Whoa. Yeesh. Any other questions there? Do you guys know what a protractor is? Yeah?
Yes. We're going to need one for the test, aren't we?
You may have one for the test. You can bring your own, or I have one up here for you. Okay. What must the size of angle 1 be? And just there's one final question for this page. Angle 1. What must the size of angle 1 be in order for L1 and L2 to be considered parallel? What do you think? Sorry? Okay, one of the answers is 123. Anybody have a different answer or confirm that? Why would you say 123? Go ahead and explain.
57 degrees and it's complementary.
Okay.
Or it's
It- Supplementary.
Supplementary.
Right. Yeah, it is. Now let's take a look at this. This angle and this angle right here would be supplementary, those two. And this angle, the black one and 1 would be identical because they are corresponding. So that means that 57 and 1 would be supplementary. So 180 degrees minus 57 degrees is 1, you said 23?
27.
23? 123? Awesome. I believe that is correct. That seems correct to my tiny brain. So if you guys are good with that, then yeah, good. All right, clipping right along here. It's a good review, chapter 5. You guys are on the roll here. Okay, a quadrilateral is a four-sided figure. Triangle, 3. Quad, 4. Four-sided, closed four-sided figure. So quadrilaterals all have 4 sides. What are the types of quadrilaterals that we need to study here? A parallelogram is one type of quadrilateral where there are 2 pairs of parallel lines. Those opposite sides are parallel. Okay, opposite sides have to be parallel. That's called a parallelogram. A kite has 2 pairs of congruent sides and the diagonals intersect at 90. So this is a traditional sort of kite shape. This is what is the big deal about a kite. We have these 2 sides are equal, like it's like an isosceles there, and another isosceles here. And this middle line is kind of like a line of symmetry between the 2. So that's a kite, okay? And a trapezoid has 4 sides, but only 1 pair of parallel sides. So parallelogram has 2 pairs of parallel sides. Trapezoid only has 1. The second set of sides do not have to be parallel. Okay. So let's go back to parallelogram. What else can we know about parallelograms? Well, a rectangle is a parallelogram, and so is a square, I guess, right here. Rectangles have opposite sides equal length. Square has all sides equal length. I think, and you guys know very well the difference between rectangles and triangles. A rhombus is a parallelogram with 4 congruent sides, and it's kind of like a square that's been pushed over. Think about it that way. Someone has just pushed on that square, and it all had 90 degrees, and then all of a sudden, boom, it's just kind of like tilted over, like a barn that's falling down or something, right? So that's what a rhombus is, okay? Rhombus. I was going downtown, but I missed my destination because I got on the wrong bus. No? Okay. All right. Wrong bus. I don't know. There's the right bus and there's the wrong bus. I'm sorry. I apologize.
It's okay.
It's not funny. Okay, trapezoid. What kinds of trapezoids do we have? We have a right trapezoid where we have 2 right angles, like this. Okay. And we have an isosceles trapezoid where the 2 non-parallel sides would be the same length. Okay. So that is a very, very good page to study. And if you're making a study sheet, you might want to redo these tonight or whatever and make sure that you have those committed to memory, or at least be very familiar with those for tomorrow's test. Do you guys have any questions? All right, the final section. The final section is 5.3, and when we talk about regular polygons, we're talking about shapes that have all the same side lengths. All the side lengths are the same. So a square, right, is a regular quadrilateral, okay? They're all the same side length. And triangle has 3 sides, quadrilateral, as we said, has 4, pentagon is 5, hexagon 6, and so on. So this chart, in one of your questions in your test, you may say, we have a nonagon, and blah, 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 and you have to know what a nonagon is. It's a shape with 9 sides, right? So you may have to know that. So be familiar with these terms. And a polygon is a closed figure of 3 or more sides on lying in a single plane. So just a 2-dimensional shape, not a 3-dimensional. All right. And as I mentioned, a regular polygon has sides with all the same length. Okay. So we have a regular triangle here, looks like. All 3 sides may be the same there. Maybe. I have to measure that out. But we have a big square here, looks like. Looks like we have a 1, 2, 3, 4, 5, 6, 7, 8. Did I count that one? It looks like a 1, 2, 3, 4, 8-sided figure here. What's that one called? 8-sided?
Octagon.
Octagon. Think about the octopus with 8 legs there, or 8 tentacles. So octagon and so on. Yeah. Okay. All right. So this is important here. This is what we'll wrap up with here. Just some kind of technical stuff here. When we talk about a regular polygon, we can talk about the interior angles. So you've all done questions like this, but let me just highlight this for you. An interior angle for a polygon would be, now let me just draw just something a little simpler. So that's a triangle. This is an interior angle. That's an interior angle, and that's an interior angle. If you have something like this, a hexagon, okay, the interior angles would be these ones right here. And if you had a regular, let's say a regular hexagon like this down here, all the sides would be the same, and therefore all of the interior angles would also be the same. Now don't let these diagonals confuse you. Interior angles would be right here. Okay? So how can we find out what those angles are? Well, there's a handy dandy little formula that you guys, again, this is review, so hopefully you've seen this before. But the sum of the interior angles is given by 180 times the number of sides minus 2. So for example, for the hexagon, the sum of the interior angles would be 180 times, well, there's 6 sides in this, so that would be 180 times 4. Okay, so what's that? 400 and 320 and 720?
Yes, sir.
So 720 degrees. So all of these angles that I've started outlining in black here would all add up to 720. Now if this was a regular hexagon, this one right here, notice, do you know where this 180 comes from? It comes from the number of triangles that kind of can be set inside of this. So watch this. If I drew a line from here to here, there's a triangle I just made. See that? And if I drew another line from here to here, well, that's another triangle I just made. The second one. There's 1, there's 2. And if I drew one more line from this same point, I've now made 2 more. So I've got 1, 2, 3, 4 triangles that can set inside this right here. And if, you know what? If we add up all of the angles in these 4 triangles, we get 720 degrees, and that just happens to be this angle plus this angle plus this angle plus this angle plus this one plus that one. The sum of the interior angles. And if you wanted to find out the measure of one single interior angle in a regular polygon, then you would take the sum, which we just learned about right here, 180 times n minus 2, and divide it by the number of angles that you have. And that's, you take the sum divided by the number that you have, and you get each individual interior angle measure. Okay. I'd probably like to just maybe finish off with one question there with you. So let's take a look at 5.3. Let's see if we can come up with a good question just to finish off our review. Oh, well, there's a hexagon. Let's try and find something different. Okay. I know I worked with some of you on this question here.
Yeah, that was one of the questions I had.
That was one of your questions? Awesome.
Yeah.
Okay, let's take a quick look at practice your skills on page 210. Let's take a look at question number 1. All right. So each angle in a regular polygon has a measure of 162 degrees. So if you could envision this, 162 degrees or so, 162, that's what each interior angle of this polygon is. So is this a triangle? Is this a quadrilateral? Is it a pentagon, a hexagon, a heptagon, whatever? How many sides does this end up having? Well, you could kind of like maybe guess a little bit if you tried to draw, you know, all the angles the same size, 162. You might come up with something. I don't know. That's close. How many sides is that? 1, 2, 3, 4, 5, 6, 7. That would be a guess. But how do you know if you're right? Well, let's go back to the formula. The formula is really important here. So what is the formula? Well, what we know is the sum, okay, the sum of all the angles is 180 times n minus 2. Each angle is 180 times n minus 2 divided by n. Each angle. And what am I given? I'm given the value of each angle. So knowing these two things, I'm going to use this formula right here, or this relationship, and I'm going to fill in, instead of this each angle part, I'm going to fill in here 1, 6, 2. Okay? And what this will give us is how many sides. That would be n. We're going to be able to solve for n. Okay? Now, two ways you could do this. You could kind of like just take a guess, say, oh, let's try 7, or let's try 8, or let's try 10, or let's try 5, or let's try. You could do that and come up with the right answer eventually by trial and error. At this level, you don't want to use trial and error. Okay? You want to try and work with the equation, work with the relationship here. So how do we do that? This is how you would go about working with the equation, so you don't have to just keep guessing over and over. Let's multiply both sides by n. Okay? What does that do? Well, that gets rid of the n in the denominator on the right side. And I'm left with 162n equals 180n minus 2. Well, if I now multiply 180 into these brackets, I get this. 180n minus 2 times 180 is 360. And some of your algebra skills from previous classes might be kicking in now, and you say, okay, I need to solve for n. I have two like terms. I am going to get them together. And what you maybe want to do is subtract 180n from both sides. So you're left with, and I'll just write this up here now, you're left with a negative 360 on the right side. You see that? Negative 360. And what's 162 minus 180? Well, that would be negative, what, 18? 18n. Okay, because you have 162 n's and you have, take away 180 n's. You have negative 18 n's. Finally, the final thing you do is now divide by negative 18. So what is negative 360 divided by negative 18? Okay, it is. I'll take your word for it. That is totally true. It is positive 20. So guess what? This is how many sides. That's what n equals. N equals 20. And so the number of sides is 20. So it's 20-sided. 20 sides. And we've got that from our equation there. No, obviously my drawing was not quite accurate, right? What did I guess? Like 6, 7, 8 sides, something like that? So 162. So it's going to be a lot more than my guess, which is why you don't just kind of like sketch it out and guess. You want to use, and if you were to do trial and error there, you might have been checking for a long time before you got to 20.
I did it a little bit different.
Okay. Okay, so 20 sides, yeah, is the answer. And like I say, I would strongly suggest working out the math like that, solve it algebraically, and then you won't have any issues. No guesswork at all in there. Okay, so make sure you circle your answer and all that sort of stuff. Okay, so that is chapter 5. And do any of you have any questions at all with that? With anything from chapter 5 that we can finish off with here?
I've got a